So there's an awful lot of things we could cover for tips and tricks, and we've had such great presentations today that I'm cutting this a little short, and I'm going to continue on the trend of looking at some LiDAR data. But we have some really interesting new tools for selecting LiDAR based on their proximity. And this is really useful for things like encroachment analysis. So I've got an example here. This is some terrestrial LiDAR that has been classified, and you can see I've got some rail lines here. These actually came from, this is the Raleigh area, so these came from the state Department of Transportation. These are the actual rail lines in this area. And actually, if I turn off the point cloud here, you'll see in the imagery as well. I'm right on top of this rail corridor. So one way to use this new tool, this is the Select LiDAR by Distance tool. I'm just going to highlight it in the toolbar here. This was added in 20.1. Would be to pick up on some of the points in the point cloud that might be sort of coming into this zone that we need to protect, make sure it stays cleared from things like brush or development. So I'm going to use this tool to find those locations and kind of highlight those, maybe as a way to kind of speed up the process for sending people out manually on the ground to go figure out where they need to do some brush cutting or things like that. This is being used kind of across the board in infrastructure, utilities, et cetera, to kind of automate a lot of this process of maintaining these corridors. So I've got my railroad lines loaded. I'm going to open this tool. So fairly straightforward here. I want to select in the end here, I'm going to take a look at the high vegetation specifically. Right now I'm coloring my LiDAR by classification, so you can see the green areas are the vegetation. I can search near other LiDAR points, so maybe I want to find vegetation near building points or something like that. That use case can be really good for things like sort of cleaning up in a semi-automated way some of the auto classification tools. In this case, what we're going to do is search near the loaded 3D line features. This works with either 3D lines or 2D lines. We can choose whether to use a 3D distance measurement or a 2D distance measurement. In this case, actually, since I'm railroad tracks right on the ground, I probably don't need the full 3D. I kind of want all of the brush in that area, whether it's low to the ground or high up. So we can sort of simplify that here. I'm going to reduce the search distance a little bit. So this is similar to a buffer. We're looking for points, ultimately, that are going to be selected that are near to these rail lines. And I will go ahead and run that. And this is going to select a bunch of LiDAR points that are kind of inside of this encroachment zone. And that was a nice little quick analysis here, but some next steps in this case might be to actually come up with some coverage polygons here to kind of maybe have some targeted areas to send people out to do some brush clearing. So I'm actually going to use the vector extraction tool to do that. So I'm going to extract tree points and tree coverage polygons for only my selected points. So this is going to give me some nice target areas to go out and search for. And let's turn off the power lines here. So I think I can just stick with the default settings here. We just want something that's a little bit simpler of geometry than just a whole bunch of points to kind of give us some target areas. And this is going to come up with basically different clusters of tree points that we could say are kind of one set of areas that we might go out and search for. And it's doing a quick calculation of height above ground. If you're not familiar with some of our LiDAR analysis tools, this is also something that you can visualize and extract from the LiDAR data as well. So based on that ground classified surface, we can determine things that are above ground and how tall they are above the ground. So that can be really useful for some of these forestry applications or urban environment applications as well.
So quick question here, I'm just going to read them while we're waiting for the status bar. Somebody asked, is it required that ground points are present before you do that detection of tree points? Is that a requirement? Do we need to know where ground is, in other words, before we identify trees?
So it depends on how you're going to do your search by distance selection. If you want to do a classification, then you would need classified tree points or whatever the class that you're looking for. In terms of our automated algorithms, you need to identify ground before you can auto-detect buildings and trees.
Right, I think that was the question was related to that. Obviously a tree or a ground point is identified related to its position relative to ground.
So I'm just going to turn off the point cloud for a second here, and we can see now some of these areas that we might want to send a crew out to maybe do some trimming in this area. So this is a really powerful tool for things like encroachment detection. If I have a second here, I'll show a slight variation. So if you don't have a classified point cloud, or maybe if you're just looking for a different use case, maybe something like the paint lines on the road, we could also do a similar analysis looking at the color. So just so we can see what's happening here, I'm going to switch this to color by RGB. This is RGB that has been applied from this ECW image that is loaded. So this was taken at the same time as the Lidar data was collected. And it is a nice aerial image of this area. I'm going to clear my point cloud selection here too, just so we see what's going on from the beginning here. So as opposed to specifically collecting vegetation class, I could actually try to pick up on points that are green, basically. So a similar idea. We could also think about the same thing in the context of roads. Maybe I'm looking for white paint or yellow paint or something like that. So let's do a very simple example of that. So again, I'm going to search near my loaded railroad lines. So bottom here, I want that. And then up here, instead of just selecting by classification, I'm going to go into these advanced options, and I'm going to add a color. So I want to go ahead and pick up on a color. I do have my image turned on here, and that's going to allow me to actually extract that pixel value of that image. And I'm just going to go somewhere in the vegetated area here. And just for safety here, I might do just a second shade of green here to make sure we get a little bit of a range.
And while Kat's doing that, those of you who were with us from this morning, Patrick in his introduction to Global Mapper introduced that color picker as one of the recent additions to our toolkit, and it's got a lot of applications, this being one of the situations where you have this automated color extractor.
So I'm going to keep ladder points close to this rail line, or this rail line, based on their color, and I am doing a little bit of what we call a fuzziness around that color, so a few different shades of green that I want to include, not just that specific RGB value. And we will run through this example again. So again, you could think about that in the context of, maybe paint lines on a road where you can kind of assist with doing some semi-automated classification. But in this example here, we're looking at those vegetation points based on their color. So really getting that that particular type of vegetation. It looks like some of the other areas here might be leaf off, so we might need a different thing to do with that. Maybe we take a look at something like NDVI for that area as well. But yeah, it opens up a whole bunch of new possibilities for kind of assisting, bringing intelligence into our point cloud. So that is our new Select Lidar by Distance tool. There's a bunch of other new LiDAR tools which I didn't have a chance to cover before, but let's try a couple of these on this particular point cloud. So another new one, especially with the photo-generated point clouds, this can be really helpful. This is a spatial thinning tool. This can reduce the density of the point clouds. This particular set of data is actually Geiger mode data, so it's also pretty high density, about 50 samples per square meter. And there might be, depending on the use case, some cases where we don't want these 25 million points. Maybe we want to share it with somebody that doesn't really have the computing power for that, or we're trying to put it up on the internet, or there might be reasons where we want to thin out some of the data in certain areas that we don't care as much about. And actually, let's go ahead and I'm going to draw an area feature here, and we'll just thin out a selected area with this tool. So I'm going to open the spatial thinning tool and go ahead and thin only my selected LiDAR points. I can thin based on average point spacing, that is a calculated statistic of the layer, or a specific linear unit. Let's go a pretty large thinning here. We'll go all the way down to 1 meter. There's a few different methods I can use for how I'm doing thinning. Probably the most intelligent is this 3D method, where I have one resolution for the horizontal accuracy that I'm trying to keep, and then a separate resolution that I can set for the vertical accuracy. This actually uses three-dimensional sort of boxes of points as I do the thinning. So I could set that to something a lot more detailed, like 1 point spacing that's going to keep, all my buildings, all my tree points, etc. And actually, let me just make sure yep, so that created a new layer here. So let me turn off the original. There's a few options. You can put this in a new layer, like I've done here. You can also update the existing layer. That's a new option as well. So if I wanted to update my existing layer, I would just check that new option at the beginning, mark the points as deleted, and those would thin out in my loaded layer. So yeah, lots of new tools for working with LiDAR points. I had a whole bunch of other workspaces related to some of our exciting raster analysis tools, looking at Landsat data, but we'll have to perhaps do that in a webcast in the future.
Maybe we'll have to do another GeoTalk sometime to let you do that. Yeah, there are resources on our website that we have in a section of webinars. If you do not already subscribe to our YouTube channel, I recommend you do that. Kat is featured prominently on there with some of her expertise as well.
As is David.
And we'll continue to update that when we have time, introducing some of these new tools, giving you them in a real world context. Thank you once again, Kat, for your expertise. As we said this morning, and it was very interesting, I paused after Kat's presentation and reminded people that if you want to expand your knowledge of Google Map, or maybe using some of the tools that Kat showed us, or some of the functions we weren't able to cover today, training is the best way to do that. I got back from a class last week down in Florida, and the takeaway for most people is I didn't realize there was so much in there. So it really is a beneficial addition to your knowledge to be able to attend the training class. You'll see on the screen the classes that are coming up. And again, if there's other locations you may be interested in, it is based on demand. Website at the bottom, you will note you can send us an email to training@bluemarblegeo.com. If there are specific venues that you would like to see, and if there's enough interest, we will certainly put that on our tentative plans. So